According to the National Electrical Code, it is not permissible to route lighting circuits from a new electrical panel into an existing panel and then through a single conduit to a junction box. This configuration violates several key provisions of the NEC, specifically sections 300.3 Bone and 300.3 B2. NEC section 300.3 Bone addresses the concept of installing circuits as a unit. This section mandates that each service, feeder, and branch circuit must be installed as a complete and independent unit. The underlying principle is to ensure that each circuit originates from a single point of origin, which is the overcurrent protection device, and maintains its integrity throughout its entire path. The code prohibits the practice of splitting a circuit's origin across multiple panels. In a described scenario, the light circuits would be originating from two distinct electrical panels, which directly contravenes the requirements outlined in NEC section 300.3 Bone. The circuits are not maintained as a single unit, but are instead artificially divided across two separate sources of power. Secondly, NEC section 300.3 B2 further reinforces the principle of circuit integrity by stipulating that each branch circuit must terminate at a single overcurrent protection device. This means that the entire branch circuit, from its source to its termination point, must be protected by only one overcurrent protection device. The code aims to prevent situations where a single branch circuit is protected by multiple overcurrent devices, which could lead to coordination issues and potential safety hazards. By routing the light circuits through two electrical panels, one would inadvertently be violating the requirements of NEC section 300.3 B2. The circuits would effectively be passing through the overcurrent protection devices of both panels, which is not permitted under the code. The proper method for adding more circuits involves two primary options. Firstly, one could install another conduit run from the new electrical panel directly to the junction box. This approach would maintain the integrity of the new circuits by providing them with a separate and independent pathway from their source to their termination point. This pathway would not involve the existing panel or its associated overcurrent protection devices. Secondly, one could rewire the existing lights to terminate directly at the new electrical panel. This approach would consolidate all of the lighting circuits within a single panel, eliminating the need to route them through the existing panel. It is essential to carefully consider the existing wiring and the load requirements of the lighting circuits to ensure that the new panel has sufficient capacity to accommodate all of the circuits. Now, let's elaborate further on the implications of these code violations and the recommended solutions. When circuits are run through multiple panels, it can create confusion and potential hazards during troubleshooting and maintenance. Firstly, it becomes difficult to identify the source of a particular circuit as it could originate from either of the two panels. This can complicate the process of locating and resolving faults, as technicians may have to trace the circuit through multiple panels to determine its origin. Secondly, it can lead to overloads and potential fire hazards if the combined load in the conduit exceeds its capacity. The National Electrical Code specifies the maximum number of conductors that can be installed in a conduit of a given size. If the combined load of the circuits from both panels exceeds this limit, it could cause the conductors to overheat and potentially ignite. Thirdly, it can create coordination issues between the overcurrent protection devices in the two panels. The overcurrent protection devices are designed to protect the circuits from overloads and short circuits. If the circuits are run through multiple panels, it can be difficult to ensure that the overcurrent protection devices in each panel are properly coordinated. This can lead to situations where one overcurrent protection device trips before another, potentially causing unnecessary outages or even damaging equipment. Now let's delve further into the details of installing a new conduit run. When installing a new conduit run, it is essential to carefully consider the following factors. Firstly, the size of the conduit. Secondly, the type of conductors to be installed. And thirdly, the route of the conduit. The size of the conduit must be sufficient to accommodate the number of conductors to be installed. The National Electrical Code provides tables that specify the maximum number of conductors that can be installed in a conduit of a given size. These tables take into account the size of the conductors, the type of insulation, and the directing factors that may apply. The type of conductors to be installed must be suitable for the application. The National Electrical Code specifies the types of conductors that can be used in various applications. For example, conductors that are installed in wet locations must be specifically rated for wet locations. The route of the conduit must be carefully planned to avoid obstructions and to minimize the length of the run. The conduit must be supported properly to prevent it from sagging or becoming damaged. Now let's explore further the details of rewiring the existing lights to terminate at the new electrical panel. When rewiring the existing lights, it is essential to firstly carefully identify the existing wiring, secondly determine the load requirements of the circuits, and thirdly ensure that the new panel has sufficient capacity. The existing wiring must be carefully identified to ensure that the new connections are made correctly. The National Electrical Code specifies the color codes that must be used for wiring. For example, the grounded conductor must be white or gray, and the equipment grounding conductor must be green or bare. The load requirements of the circuits must be determined to ensure that the new panel has sufficient capacity. The load requirements can be determined by measuring the current draw of the light or by consulting the manufacturer's specifications. The new panel must have sufficient capacity to accommodate all of the circuits. The capacity of the panel is determined by its ampacity rating, which is the maximum amount of current that the panel can safely handle. In addition to the above considerations, it is also essential to comply with all applicable local codes and regulations. Local codes and regulations may vary from the National Electrical Code and may impose additional requirements. It is always advisable to consult with a qualified electrician to ensure that the electrical installation is safe and compliant with all applicable codes and regulations. Let's delve into some additional considerations regarding overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are critical components in any electrical system. Their primary function is to protect circuits and equipment from damage caused by overloads and short circuits. When an overcurrent condition occurs, the overcurrent protection device will trip or blow, interrupting the flow of electricity and preventing further damage. Firstly, it's crucial to select the correct size of overcurrent protection device for each circuit. The size of the overcurrent protection device should be based on the ampacity of the conductors in the circuit. The ampacity of a conductor is the maximum amount of current that the conductor can safely carry without overheating. The National Electrical Code provides tables that specify the ampacity of various types of conductors based on their size, insulation type, and installation conditions. Secondly, it's important to ensure that the overcurrent protection devices are properly coordinated. Coordination means that the overcurrent protection devices are designed to trip in a specific sequence such that the overcurrent protection device closest to the fault will trip first, minimizing the extent of the outage. Improper coordination can lead to nuisance tripping, where overcurrent protection devices trip unnecessarily, causing disruptions to the electrical system. Thirdly, it's essential to regularly inspect and test overcurrent protection devices to ensure that they are functioning properly. Overcurrent protection devices can degrade over time due to factors such as corrosion, vibration, and temperature fluctuations. Regular inspection and testing can help to identify and replace faulty overcurrent protection devices before they fail to operate when needed. Let's now discuss some additional aspects of conduit installation. Conduit is a protective raceway used to enclose electrical conductors. It provides mechanical protection to the conductors and helps to prevent them from being damaged by physical hazards, moisture, and other environmental factors. Firstly, it's important to select the appropriate type of conduit for the application. The National Electrical Code recognizes several types of conduit, including rigid metal conduit, intermediate metal conduit, electrical metallic tubing, flexible metal conduit, and rigid non-metallic conduit. The type of conduit to be used depends on factors such as the location of the installation, the type of conductors to be installed, and the environmental conditions. Secondly, it's crucial to properly support the conduit to prevent it from sagging or becoming damaged. The National Electrical Code specifies the maximum spacing between conduit supports based on the type and size of the conduit. Conduit support should be installed at intervals that are close enough to prevent the conduit from sagging or deflecting excessively. Thirdly, it's essential to seal the conduit to prevent moisture and other contaminants from entering the conduit. Conduit seals are typically used at the ends of conduit runs and at any points where the conduit enters or exits an enclosure. The type of conduit seal to be used depends on the type of conduit and the environmental conditions. Finally, let's consider some additional points related to wiring practices. Proper wiring practices are essential for ensuring the safety and reliability of electrical systems. Firstly, it's important to use conductors that are properly sized for the application. The size of the conductors should be based on the ampacity of the circuit and the voltage drop requirements. The National Electrical Code provides tables that specify the minimum size of conductors for various applications. Secondly, it's crucial to make proper connections. Connections should be made using approved connectors and should be tightened to the proper torque. Loose or corroded connections can cause overheating and potential fire hazards. Thirdly, it's essential to protect conductors from physical damage. Conductors should be protected from abrasion, impact, and other physical hazards. This can be achieved by installing the conductors and conduit or other protective raceways. In summary, the practice of running circuits from multiple panels through a single conduit violates the National Electrical Code and can create potential safety hazards. The proper way to add more circuits is to either install another conduit run from the new panel to the junction box or to rewire the existing lights to terminate at the new panel. It is essential to comply with all applicable codes and regulations and to consult with a qualified electrician to ensure that the electrical installation is safe and compliant. Furthermore, remember to prioritize safety when working with electrical systems. Always de-energize circuits before working on them, use appropriate personal protective equipment, and follow safe work practices. By adhering to these guidelines, you can ensure the safety and reliability of your electrical system.